maintainability and testability. So when you're writing software, you need to think about how you're going to maintain it, and more importantly, how you're going to test it. All right, so let's have a look at an example of a bad calculator. Now, this is a calculator that has a super complex calculate method. We have all these kind of nested statements. We're dealing with tries and excepts and with statements. And we're just doing like so much stuff that at first glance, it's very difficult for us to understand what this function does. And if I wanted to test it, there's like 30 different examples of things that could happen in this function. So how do we make that better? Well, we go to this example. Notice here, I now start separating things into smaller components like we talked about earlier that are easier for me to test. I have a calculation result. Easy for me to check if the calculation result is correct. I have an operation parser. Rather than just passing a whole expression, I now pass an expression to one function, and this function is purely responsible for parsing the expression. That's a lot easier for me to test, right, than a whole calculator function. Then I have my calculator, and look at how much simpler this function is. I have A, an operator, a B, I get the operation, I perform the operation, and boom, I can test this, and it doesn't take a million different edge cases. Hopefully you get the idea. Again, it seems more complex, it takes more time up front. Good code is difficult to write. That's why we have senior developers. People still get paid a massive amount of money, and I guarantee you if you ask AI to generate this style of code, it's not always going to make the best decisions, and you need to know deep down what the correct architecture and design is, which is why I'm showing you these patterns.